Cisco Extended Detection and Response, configuring NetFlow on a Cisco Catalyst Switch. So in this video, what we're going to do is we're going to kind of go through a generic NetFlow configuration on a Catalyst switch, a generic Catalyst switch. It's not going to get specific to, any model, 3850s or 9300s or anything like that. It's just basically this config should work on most newer Catalyst switches and a lot of the older Catalyst switches too. On the different models have a lot of idiosyncrasies that may be specific to a model, and I can't really go through every single one of those for every single model and every single version of code running on all those. But this should work. The configuration we're going to kind of go through should work on most Catalysts with modern iOS on them. So here's the basic NetFlow config we're going to be using. Looking up in the upper left under flow record, you're going to see I have a description for the first part, NetFlow record format to send to XDR, and then there's 9 fields of information. You'll hear us sometimes refer to this as the 9 tuples of NetFlow. These are basically the minimum NetFlow tuples that you should be sending to pretty much any solution that's going to consume NetFlow. Now there's optional fields, and you see right below that I'm adding in an optional flow record field for collecting transport TCP flags. We have the mandatory ones, those 9 tuples. Cisco XDR can consume some other information as well, and since this switch can send it, that I'm actually doing this on, I'm going to also send along the TCP flags that are available with it too. Now, not every system can consume every optional setting. There's a whole bunch of them that we might look at when we start doing the router ones too, and some of the newer 9300 and 9400 switch series can send a lot of extra optional fields, but not every solution can necessarily consume all that and use it for detections. Okay, the next piece below is the flow exporter. So the flow record, like above, that shows you what we're going to be sending. The flow exporter tells us where we're going to be sending it to. And you can see I'm sending it to this particular IP address, 192.168.5.250. My source interface is going to be VLAN 5, and I'm sending it on UDP 9995, but there's a configuration below that called template data timeout 30. I'm going to talk about that in a minute. And then the flow monitor command, that actually takes the record and the exporter, combines them together, and that is going to be a reference that we put on the interfaces we're going to be collecting flow on. And you can see 2 other settings, cache timeout active and cache timeout inactive. I'll talk about those in a minute too. But how do we apply this? If you look up there on the right-hand side, you can see I have flow monitor on physical interfaces, trunk interfaces, and you can even put it on your VLANs too. And I have IP flow monitor, XDR flow monitor input, and there's an output. Now, not every switch can do input and output. We'll talk a little bit about the difference in the 2 of those, input and output, and where we should be collecting this information. For our demo, we're just going to be doing the IP flow monitor input. We'll be putting that on our layer 2 interfaces. And when I talk about interfaces that we should be collecting information on, it'll make a little bit more sense at that point. But I just want to show you what is available here. And then in the lower right, of course, the validate configuration commands. Okay, a little bit more information on some of those configurations that I talked about. The first one, template data timeout setting, also sometimes called the template refresh timeout. It configures the interval at which the NetFlow templates are sent to the NetFlow collector. So what's a NetFlow template? NetFlow templates define the structure of the flow records that are being sent by the exporter, along with what types of data fields will be included, those 9 tuples plus that optional field that I was sending for TCP flags. NetFlow version 9 then uses these templates to provide flexibility in the types of flow that can be exported. And the template timeout ensures that the templates are periodically refreshed, sent to the collector to prevent mismatches between the flow data that is being sent and the collector's expectations. So, and for our example, we set the timeout data limit to 30, which means that NetFlow templates will be sent to the collector every 30 minutes. This periodic refresh is important because it ensures that the collector has up-to-date information about the structure of the flow records it will receive, which helps to ensure that accurate parsing of the analysis and the flow data itself. Now, the cache timeout active setting specifies the duration for which active flow records are maintained in the cache before they're exported to the NetFlow collector. That's our P&M sensor. An active flow is one that's currently being monitored, such as ongoing communication sessions between two devices. The cache timeout setting ensures that even if the flow is still active, its details periodically are exported to provide as close to real-time visibility into the network traffic patterns as we can get. So for security deployments like we're talking about with Cisco XDR, the cache timeout, I've set it to 60, which means that every 60 seconds, the active flow records are exported from the cache to the collector, regardless of whether or not the flow is still going on. Now, some switches, the default setting is actually 30 minutes, and that's just too long for security type configurations. You'll look in there and it'll be configured for 30 minutes worth of seconds, which I think is what, 1800? Does that sound about right? Anyways, this makes sure that we have some real-time information for security purposes. Now that 30 minutes can be used, it's fine for non-security related stuff if you're using your NetFlow for that. But when it comes to security, it's always a good policy to get it down to at least 60 seconds, send it every 60 seconds. And finally, the cache timeout inactive setting specifies the duration after which inactive flow records are expired and removed from the cache. So an inactive flow is one that's had no packet activity for a certain period. The purpose of this is to make sure that the that flow records for sessions that have ended or become idle are efficiently cleared from the cache to make room for new flow data is really what it's all about. This helps managing the cache memory on the switch and ensuring that NetFlow cache doesn't get filled up with stale data. So if you're in our example here, I set it to 15. It means that flow is not seeing any activity for 15 seconds. Its record will be removed from the cache. And this helps in maintaining, an accurate view of the network traffic. So we don't want those flows to persist forever or indefinitely inside the cache. Okay, now I'm going to try and talk about where we should be applying that IP flow monitor input and output command. So what you're looking at here is my attempt to kind of draw out a switch, a possible switch that has both layer 2 and layer 3 interfaces. And you can see all those dots at the bottom down there. Think about that as like layer 2 interfaces where you'll plug a workstation in with an RJ45 jack or something like that. Then of course the VLAN, that's the routable VLAN. Layer 3 up there, the VLAN 100, 101, and 102. That's what I'm trying to show with that. And then, of course, on top of that are like trunked interfaces with a port channel around it. So you can put that command to apply the flow monitor to any one of these except the port channel. You can actually put the command on the trunks. Don't put it on the port channel. Even though some Cisco switches will actually accept the command, it doesn't actually work there. So you put the IP flow monitor inputs on the trunked interfaces that are part of the port channel, and it'll work. Everything will work just fine for you. So that's a weird little thing. They don't all accept it, but some of them do, and it's strange, and I don't know what to do about that. Anyways, but down at the layer 2 interfaces, this is actually the preferred area. So those all those white dots down there at the bottom that I'm trying to show as an example of a layer 2 interface where you plug an RJ45 port, connector into. If you can take your NetFlow there, that is what most networkers will tell you is the optimum place to put it. The problem comes in is that not every switch out there can necessarily do NetFlow. I mean, you might have some older models, or models that aren't Cisco switches, or that are a little bit cheaper, that maybe don't have that capability to consume NetFlow. And so you might actually have to do it at the layer 3 interface up there where the VLANs are, because everything is going to go back to that routed network. But if you can, if your entire infrastructure allows you to do it, think about it. If you put the IP flow monitor input command on every layer 2 interface, so you will capture all the flow session going on inside of your environment. So if you, in this example, like this far one on the left, let's say that's a workstation is plugged into here and it's talking to a server that's over here on the far right interface. If you use the input command, You're going to see the request come from the workstation. It's going to go out to the server in the far right port, but we're not worried about that because we already captured that flow data on the input. And then when the server responds, you're going to catch the input from the server going back to the workstation. So it's going to see the entire flow session without having to capture both the input and the output. Now, the catch, like I said, not every device can do flow, and you probably have some wireless, and there's some wireless devices, they can't capture flow data either. So you may not actually be able to consume flow data until it gets to, a higher end device. And then, maybe you capture it on the interface going into that device, or oftentimes on the VLAN itself. That's why I have the layer 3 in here. So I knew this was going to be difficult to explain. But anyways, if your device can do at the layer 2, and that's the example I'm going to be showing here, then that's going to work great, because I'm going to put it on all the layer 2 interfaces, and I'm putting it on the trunked interfaces too. You can see up there like that 1/25 and 1/26 example, like that's going up to our core switches or something like that. And and any response coming back from somewhere else, it's going to go in on another layer 2 interface. But if you're in doubt, if you're having difficulty with it, or if not all your devices can, it's perfectly acceptable. Go ahead and put it on the layer 3 VLANs. Put it on as input and output if you are just worried that you're going to miss some flow data, because the goal here is to make sure we see all the flow sessions running around inside of our environment. And if you're worried you're going to miss something, go ahead and put it there. It's not a horrible thing. You're not breaking any cool concepts or anything. And the good news is that with Cisco XDR, it's going to take all that flow information. So even if you duplicate it, it's going, when you send it to the flow collector, it's all, and it goes up in the data lake, it's all going to be, all that flow data is going to be stitched together. So all the session information related to a session gets stitched together, and then it gets deduplicated anyway. So if you took more than, you took flow from more than one location and it got the exact same flow data from more than one location, don't worry about it. It's not going to fill up any database or anything like that. It's going to be deduplicated and like I said, and stitched together, so you're going to have good session data from all the communications going on in your environment anyways. So I'd really rather have you overdo it than underdo it, than have a hole in your network somewhere because you couldn't get it down on a layer 2 interface and you thought, well, that's the preferred method, but it doesn't, or you missed it somewhere. Perfectly fine, go ahead and put it at the layer 3 interfaces as well. And honestly, I find that when people are first rolling this out, it can be a heavy lift to go around to all of their access switches that, they probably have a significant amount of them, but maybe they only have, a few distros or something where all the layer 3 stuff is. So they'll do it right there just to get a good start, get a quick start on everything at that layer 3, just where all the layer 3 stuff is in their distros or something like that. Perfectly acceptable. Don't overthink it. I don't want you to overthink this too much. I just want to make sure that you do your best to make sure that you get the flow for all the sessions inside of your environment. Okay, so here we are at our switch, which I've cleverly called generic Cisco switch. Let's go into enable mode and then configure terminal. And we're going to go ahead and start copying that configuration in. Of course, we start with the flow record. Remember, the flow record defines what type of telemetry is going to be sent. So we add that in, and we've added in the required 9 tuples of information that I told you about. We're also going to add in the 10th one about TCP flags. So let's go ahead and add that one in, but that one's considered optional. If we're going to just get the minimum that we need those top 9 tuples of information there. All right, now what we're going to do is we're going to add in the flow exporter. Remember, the flow exporter is where we're sending the NetFlow information. So let's go ahead and add that in, and that looks strange because it added source VLAN 5 and transport UDP 9995 4 times for one and 5 times for the other. I did not do that on purpose. That's some kind of weird copy-paste thing. We'll check it later, but it's only going to be in there one time when we look at the configuration, I assure you. And then, of course, the flow monitor command. The flow monitor command, remember, combines the record with the exporter, associates the two of them together. Boom, we've got those in there. And then from this point, all we got to do is add it to the specific interfaces that we need to monitor. And we're going to go ahead and do that right now. So we're using the IP flow monitor and then referencing the XDR flow monitor grouping there with the input command, because like we discussed, we're going to do input on every interface going into this particular switch. So let's go ahead and add that, put it in as a range command. And then remember, we can also put this on our trunk information. So it can go on the trunk interfaces, but it cannot go on the port channel itself. So if you have a port channel with several trunked interfaces, you can put the command on the trunk interface. Now what's kind of odd is that if we did actually try to put that input command on the port channel interface, it would probably take it sometimes, but it doesn't actually work. But what we want to do is make sure we get it on the trunk interfaces themselves, not on the port channel information interfaces. So it seems to be newer versions and software specific that sometimes the command takes. It's a strange little thing. But anyways, there we have it. We have our flow record, our flow exporter, and our flow monitor configured on our device, and we also have it added to our layer 2 interfaces. Alright, I've been generating some traffic for a few minutes here. Let's go into our switch and see if we can see any traffic being sent. So I'm going to copy in the one show command that seems to be the best for some verification, the show flow monitor statistics command. And of course you have to associate that with the flow monitor we're actually interested in, because you can have more than one. And hit enter, and yes, looks like we are sending some flow data now. You can see the active timeout default to 60, inactive timeout that was to 15. Remember those configurations we sent, how many flows we've added, how many flows have aged out, what was our high water mark and such. So, but it's basically showing us that yes, the switch is actually sending telemetry to the P&M sensor. Okay, now let's do our verification on our P&M sensor here. Remember to do that, we do a TCP dump. So we're going to go sudo TCP dump from our source IP. In our particular case, our switch was sending telemetry from VLAN 5, which was 192.168.5.2. We want to do 10 packets. And here's another key that I often add in here. I don't want it to resolve addresses automatically when I do a TCP dump. I want to see the IPs. I'll put a -n on there as well. And we're listening. And we should start seeing some NetFlow come in. There you go. There's the first packet coming in. And remember, this is a lab, so it's kind of coming in as a trickle. I'm generating traffic over here as much as I can. But in a real life environment, this is probably going to come fast and heavy. There we go. Now it's starting to pick up a little bit. But we're receiving telemetry just like we should. Okay, so let's go look in the XDR portal and see if our telemetry has arrived here. We're going to go into Investigate, Event Viewer. And what we're going to do now is sort everything based on the sensor that's sending it, which is our lab PNM2 sensor. So what I've done here is I've scrolled over to the sensor column, and I'm going to type in the name of the sensor, which in our particular case was lab-pnm-2. Hit enter, and it will sort and find all the telemetry related to that was sent to this particular sensor itself. Okay, so that's been sorted, and you can see I sorted it by the lab-pnm-2, so I could just find telemetry that was sent to our lab-pnm2 sensor that we're messing around with. Looks like we're getting an awful lot going to DNS there. Those are the umbrella DNS servers. Let's scroll down, find some other stuff. Here we go. A lot of TCP 443 that I was sending, and so it looks like we're Getting all sorts of telemetry now. Let's go over here to the TCP flags. Remember I talked to you about what those were? I'm going to set this to does not equal, and then I'm going to put in the block there, and then when I resort, I should see TCP flags, and yep, there we go. So you can see I got the push flag, SYN, FIN. So looks like our optional fields are being uploaded into Cisco XDR as well. So looking back at our switch here, I hope I didn't confuse you, because sometimes this is difficult to describe. In fact, with some of my customers, I've spent anywhere from 30 minutes to an hour trying to walk them through where to collect NetFlow and how to collect NetFlow. And when it comes to XDR, you're not charged, at least at the time of this recording, by how much flow you're sending to the little PNM sensor. There are some solutions that charge you based on the amount of flow that you're sending to it, even if it does deduplicate it. I don't want to go into all those various product sets. I want to keep this focused on the XDR solution. But if you're in one of those kinds of situation, yeah, you'll probably have to be a little more discerning. But when it comes to the XDR solution, I'd rather have you send too much and let the system deduplicate it than not send enough. So if you're in doubt, go ahead and add in the inputs and the outputs, and take it at the layer threes and the layer twos if you feel more comfortable with that. Because like I said, the system's going to get rid of any duplicate data anyways.